You ask an AI, has Taylor Swift ever collaborated on a song with Stephen King? And it confidently replies, yes, Melody of the Mind, released in 2017. Sounds interesting, right? But when you look it up, completely made up. This is what we call an AI hallucination. It's not lying on purpose. It's confidently saying things that aren't real. What is hallucination in AI? Hallucination means a large model generates something that sounds reasonable, but is actually wrong. You think it's answering your question, but in fact it's just guessing. In language models, hallucinations mainly fall into two types. First, factual hallucinations. The model makes up names, data, or references. Second, faithfulness hallucinations. The answer is off-topic, illogical, or self-contradictory. You ask, who was the first Chinese person to land on the moon? And it confidently gives you a name. This isn't deception, it's probabilistic hallucination. The model isn't thinking, is this true? It's only thinking, does this sound likely? What's worse is, the model never says I don't know, even when it has no idea. It will still guess something. And these are the most dangerous hallucinations, because they sound believable. Now with multimodal models, things get more complicated. Multimodal large models don't just read text, they also look at images. You upload a picture, and it says, a girl is chasing butterflies, but there are no butterflies in the image. Still, the sentence sounds poetic. That's a visual hallucination, also called making up a story from an image. So how do we categorize hallucinations? In our survey, Hallucination of Multimodal Large Language Models, a survey, we summarize three major types. First, object hallucination, mentioning objects that don't exist. Second, attribute hallucination. The object is there, but its color, action, or count is wrong. Third, relational hallucination. The described interaction is inaccurate, like saying they're dancing around her, when everyone's actually just standing still. Where do hallucinations come from? It's not one small bug. It's a design-level bias across the whole pipeline. Let's look at 4 core reasons. 1. The generation objective is biased by nature. Language models are trained to predict the most likely next word, not to judge if a sentence is true. 2. Training data is not a knowledge base. Models learn statistical patterns from the internet, not facts or logic. They absorb fiction, errors, duplicates, and fantasy. 3. Alignment only changes the surface. SFT and RLHF help the model talk like a human, but they don't teach it what's true. It learns how to please you, not how to be accurate. 4. Multimodal models have imbalanced structures. Language modules are often much stronger than vision modules. As a result, visual signals get ignored, and image understanding turns into guessing. In short, hallucination is not a single failure. It is a side effect of imbalance, from the training objective, to model architecture, to data quality, to cross-modal design. Can it be fixed? Fixed might be too strong. Mitigated is more accurate. Current strategies include 1. Retrieval augmented generation or RAG, so the model can look things up on demand. 2. Self-reflection, where the model rewrites its own output. 3. Tool use, like calling a calculator or knowledge API. 4. Multi-agent critique, where one model generates and another reviews, but no matter how you wrap it, the core issue stays the same. The model still doesn't know if what it says is true. So is hallucination poison or magic? If you want AI to be always correct, it has to become cautious, rigid, and dull. But if you want AI to be creative, imaginative, and a bit more human, you must allow it to dream sometimes. Hallucination is the byproduct of creativity, and a test every future intelligence must pass.